In chapter 5.4 with trig ratios, we're using trig ratios to find missing angles or missing lengths on a right angled triangle. So here we have a right angled triangle. So in the last chapter we straight away labelled this one the hypotenuse. Now that's going to stay the same in this topic as well. The hypotenuse is our longest one from one point to the other. Okay. The second angle we're going to look at, now it's all based on using this. This is your angle, or theta. Okay. The side when we're looking straight across from theta is always going to be your opposite. Okay. The one that travels from the right angle here to the angle you're looking at is called your adjacent. These are the three sides that we need to know. Now if we look at it the other way around, I'm going to clear this a little bit. Okay. If we made this one theta here, okay, this is still our longest side, so that's hypotenuse. Now, if we look at opposite it, there's our opposite, it does change, making this one your adjacent. So you have to be really careful when looking at which angle we're using. Okay, to find the trig ratios, there are three simple rules or definitions that we're going to be using. The first one is sine ratio, then we have the cosine ratio, and also tangent ratio. Now you would have heard these as sine, cosine, or tangent. So sin, cos, tan. Okay. To find each of these ratios, we simplify it. We're going to write sin of angle. To find sin of angle, basically what we're looking at is the length of the opposite side divided by the length of the hypotenuse. Okay. The second one is cosine of angle. Okay. Now we're looking here as the length of adjacent divided by the length of the hypotenuse. And the third one as the tan of angle is going to be basically opposite, or the length of opposite divided by length of adjacent. Now in using these three formulas, you're going to be able to find what you need. One way to remember how to do trig ratios when we're looking at sine, cosine, or tangent, and what needs to be divided by the other, is looking at the old formula SOHCAHTOA, or the old saying, not formula. Okay, when we look at this, the first three letters are the rules that we need. Yes, obviously is sine, so we're going to put sine and put the angle. The second one is cos, and we're going to put the angle. And the third one is tan and your angle. Okay, we're going to just put the little equals here. Now, the ones we need to know is these ones here. Okay, this means opposite over hypotenuse. So the O is at the top and the hypotenuse is at the bottom. Okay, so we know sine of angle equals opposite over hypotenuse. The second one, cosine, the A is obviously adjacent, and it's going to be divided by the length of hypotenuse. The third one is opposite over adjacent, so it's going to be opposite length and adjacent length. And there you have SOHCAHTOA. Really simple way to remember. Okay, for this chapter, the question is going to require you to use a calculator. There's a couple of buttons that you need to look for. One of the buttons is going to look like this, another one would look like this, and another one's going to look like this. Okay, obviously sine, cosine, tangent buttons. Okay, another button that you're going to require is going to look like this, DMS, or it's going to look like this. Okay, these basically are the same thing. Okay, it's representing the degrees, the minutes, and the seconds, and this one's degrees, minutes, seconds, all to do with angles. As you can see up in the question, cos 65 degrees, 57 minutes. Okay, here we have degrees, minutes, seconds. You need to have these on your calculators in order to do it properly. Okay, so the work example 7 is asking you to calculate the values of each of the following correct to 4 decimal places using a calculator. Remember to first work to 5 decimal places before rounding. this is important. You need the fifth number to work out the fourth. Okay, so in your calculator, you're going to do a simple thing for question A. You're going to press your first button, which is cos. Then you're going to press 65, and in that button that I said before, the DMS, you need to press it once, then you press 57, and then you press that DMS button again to get the minutes. Okay, once you do that, you're going to have your angles, or a number that comes out like this, 0.40753. Now, 5 decimal places we have. Okay, so we need to look at these two numbers to work out whether the 5 stays as a 5 or it goes up to 6. 3 actually doesn't make it go up, so we cancel that out. So it becomes that answer there. Okay, that's all you have to do in your calculator. For part B, now you're going to press the tan button. Okay, then you put your numbers in, pressing those numbers, or those degrees, minutes, seconds buttons. So 56 degrees, 45 minutes, 30 seconds. Once you press that in and you press equals, you're going to end up with 1.52573. Okay, look at our fourth and fifth number. 3 doesn't change to 7, so your answer is going to be 1.5257. All you need to do for those questions. Okay, in work example 7, you're looking for the ratios. This time what we're going to be doing is looking for the angles, the unknown angle. Okay, and that's why it asks you here. We're going to find it to the nearest degree, and we're only given what our ratio is. And it says sine of the angle equals 0.7854. Okay, so write down what you know. So we know sine of your angle equals 0.7854. Now to work out what the missing angle is, which is this bit here, we need to work backwards. We need to remove the sine from both sides. Now in your calculator, it's nice and straightforward. There's going to be a button that looks like this with a -1 over it. That means inverse. So the opposite of sine is the inverse of sine. So you're going to press that into it. So we're going to have your angles equals, so theta equals sine, or inverse of sine, and write down your number again. Okay, when you put that into the calculator, this bit here, you're going to actually just get your answer straightforward. Okay, which is 51.8 degrees. Okay, easy as that. As long as you press control, so you're pressing the sine button as well, but before you press sine, press your control button or your function button, whatever calculator asks you to do. Okay, once you've done that, you're done. Okay, work example 9 works exactly like work example 8. Instead of doing sine or inverse sine, we're doing inverse of cos and inverse of tan. So in your calculators, you're simply going to be doing inverse of cos. Okay, put your number in 0.2547, and that's going to give you your angle. Okay, so remember to press your control, cos, and that's basically going to give you 75 degrees, 14 minutes, and 39 seconds. Now it wants us to round to the nearest minute. Here's your minutes. We know there's 60 seconds to a minute. This is over halfway, so it rounds it up. So it becomes 75 degrees, 15 minutes. And that's, sorry, one of them, 15 minutes. And that's your answer. For question B, same thing. We're doing inverse of tan this time. So we're going to put inverse of tan, put your number in 2.364, and then basically you're going to get your angle again. Okay, your angle is going to be 67 degrees, 4 minutes, and in this case 15.8 seconds. Okay, from here all you're going to do is round to the nearest minute. 15.8 isn't halfway, so it stays the same, so 67.4. Okay, and that becomes your answer. Okay, in work example 10, basically we're using what we talked about before with SOHCAHTOA. Okay, you do need to know this from now. Alright, here's our right angle triangle. For the question, it's asking us to find the sine, cosine and tangent ratios of the given angle, which is down here, okay, with our theta. Alright, first of all we need to label our sides again. Opposite the angle, well, it's opposite. The longest one, as we keep talking about, is your hypotenuse, and between the angle and the right angle you have your adjacent. Nice and simple. So we're going to use SOHCAHTOA to label, or to write our ratios down. So sine of your angle equals opposite over hypotenuse. Now if we're going to use the labeled sides, we've got A, B and C, so we'll just rewrite that as sine of angle equals A over B. Nope, sorry, A over C. The second one, cosine rule or ratio, equals adjacent over hypotenuse. Or what we could use is, well, adjacent's B, hypotenuse is C, so cosine of angle equals B divided by C. And the third one is your tan of angle equals opposite over adjacent. So opposite is A, adjacent is B. So tan of the angle equals A divided by B. And that's it. For work example 11, it's asking us to write the equation that relates the two marked sides and the marked angle. Again, we're going to be using SOHCAHTOA. Very important to keep remembering, to keep writing it down so you know it. Alright, so first of all we need to make sure we label the sides. We have opposite and we're using hypotenuse. Okay, they're the two sides we're using, and our angle is B. So if we're using opposite and hypotenuse, it must be a sine. So we're going to write sine B, or sine angle, equals 8 over 12. Now that's also written as 2 over 3 because 4 goes into both. Okay, nice and simple for that one. That's all it's asking you to do. Question B, same thing. Look at what we're using. We're using our angle. In this case we're using opposite and we're using adjacent. So if we're using opposite and adjacent, we're using tan. Okay, so we're going to have tan 40, because we know the angle is 40, equals, now opposite is x. We're not trying to answer it, we're just trying to write it out, the rules. So it's x over 22. That's your answer. Simple as that. Now that you have watched the video, it is your turn to do the work. Okay, the questions you need to finish are exercise 5.4, so that's where you should be up to now. Now, again, using your choice, you're doing practice, consolidate, or master. These are the questions I want you to do. You need to show all your working out in your books. Okay, keep writing out the rules so you get to know it. Once you've finished the chapter, check your answers from the back of the book. Fix those that are wrong. Very important. Have fun.